Okay, today we are going to take a look at the Bazel source code. This is part of a series of videos I've been doing, looking at the source code of open source projects, and mostly just peeking around, checking out what's going on, that sort of thing. I've used Bazel before. I've used both when I was at Google. I've used the Blaze system, as it's called there, and I've also used the open source version, which is Bazel. I believe that the Blaze and Bazel are at this point, and maybe always have been, the same underlying code base. They behave a little bit differently because Blaze is heavily optimized for Google's internal build infrastructure, and Bazel has to be concerned about a bunch of things that Google doesn't necessarily have to be concerned about. For example, when you're working with Bazel, you may not have every dependency checked into your source code repository the way that you would at Google. So Bazel needs some mechanism for having external dependencies, and that's in practice where a lot of the complexity comes in when you're dealing with Bazel. I'm not sure I've ever really taken a look at the source code. So let's see what we have here. I'm at their GitHub page, and let's take a look. They have a code of conduct. I'm sure that's interesting, but that's not what I'm here for right now. Examples and scripts. Site, I don't know what that is. I'm guessing maybe the Bazel website. Basics extending. Yeah, I'm going to think that, and this is all marked down. Okay, so I'm just going to assume that's the website. Let's dig into source, where I think that most of the action should be. Okay, we've got conditions, Java tools, main, test, tools, and then a bunch of BZL files. BZL being the Bazel files that are written in Starlark or Skylark. I forget what it's called at this point. Let's dig into main. And we've got C++, Java, native, protobuf, res, Starlark, and tools. I think CPP might be mainly, I was going to say C++ rules, but this doesn't really look like rules to me. So let's look at C++ and let's look at Java, and I guess let's take a look at all of these directories. They might prove useful. Okay, so inside Java, we've got com Google Dev Tools and net Starlark Java. Build. I'm not sure where the main source code is. I'm really just trying to dig into like where the actual implementation is. This is looking relatively promising. Com with Google DevTools build. Oh no, not DocGen. That does not sound like. Oh, here we go. This looks very promising. So DevTools build lib, and we're getting to a bunch of Bazel concepts that I'm familiar with, like actions, analysis, Bazel, build tool, causes, clock. Okay, so let's pull this out, and then in the browser window we have behind it, we see things like SkyDoc, which I guess I'm not going to look at right now. Skyframe, I'm not sure what Skyframe is, but maybe that's worth looking at some point. Options, invocation policy parser, isolated options. Options might be interested, but I don't think that I'm going to get to it. Starlark Java. I guess let's just go ahead and close all of this. Native is, we've got Unix and macros in Darwin and Windows. So I'm guessing that is, as the name suggests, some sort of layer for dealing with, I guess, architecture. And then we have protos. These look like it's defining proto APIs for the Bazel world. Like build.proto. Let's just take a quick look at build.proto. We've got some dictionary entries, file set entries, symlink behavior. Do we have a comment saying what this is? So the package is Blaze Query. So I guess this is a Blaze Query API. That's probably interesting, but maybe a little bit far from the central stuff I want to focus on today. All right, so here's what I think is the main window, and we've got actions analysis. Let's dig into Bazel. Okay, here we have Bazel Mod, which I think is a relatively new tool for dealing with third-party dependencies. We've got commands, coverage, debug, exec log, repository rules, and some Java files. I'm thinking, let's take a look at bazel.java. First of all, how big is this file? Not big, so there can't be too much going on in here. All right, we've got a public final class, Bazel, and a list of modules to load. And the order is important. And what are these modules? So these are all, I guess, various Bazel modules, like command log module, workspace rule module, etc. And then main is going to call Bazel version info.set build info of try to get build info. And then it's going to call Bazel runtime.main using Bazel modules and the args. This is try to get build info. It builds the standard build info map from the loaded properties. The returned value is the list of build.star properties from the build data properties file. Okay. So where's the runtime? Where's this runtime defined? Oh, Blaze runtime. Okay, so we're going to import com blah 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 lib runtime Blaze runtime. Let's see if we can find that file. So instead of Bazel, I want what? Runtime? All right. After command event, auth headers provider aggregating test listener, BlazeModule. Let's look at BlazeModule. So it looks like they're using the Blaze source code and haven't renamed a bunch of stuff, which is not surprising. Some command line thingies, info item, location printer, memory pressure event, memory pressure listener. Yeah, let's see the memory pressure module. All right, the query runtime helper, repository remote executor, I guess, server builder, spawn stats, some Starlark option parsing, UI options, UI state, workspace builder. Yeah, so far I don't have a sense of what the real entry point is, and maybe there's not really one. But why don't we go back to lib and see what else? So actions, let's take a look at the action.java. Action cache aware action. Let's just take a look at a few of these, like action graph, action input, action owner, action registry, action result, actions, file state, file value. Okay, so we've got actions. What else do we have? Analysis. Constraints, extra platform, Starlark. Actions provider, allow list, analysis issues. Aspect collection, base rule classes. Let's take a look at that. That seems possibly basic. What else? Default info dependency. Dependency seems like it might be basic. Expander. Label expander, I guess. There's just a lot here. Rule definition, run files, toolchain collection, toolchain context. Maybe let's look at some toolchain stuff. And I think that should be more than enough to fill the time I have available right now to look at this. All right. We are in BlazeModule.java. So obviously this is Java. We're importing a bunch of stuff. What do we got here? We've got a public abstract class BlazeModule. Okay. This is a module Bazel can load at the beginning of its execution. Modules are supplied with extension points to augment the functionality at specific well-defined places. All right. So this is, I suppose, different from any source code specific definition of module. This is get startup options. It's going to return extra startup options this module contributes. Okay. Return immutable list of, okay. So this is the base class, so it contributes nothing. Global init is called it at the beginning of Bazel startup before get file system and Blaze startup. Get file system returns the file system implementation used by Bazel. It's an array if more than one module returns a file system. So I guess there has to be one module that owns, in some sense, the file system that Bazel is going to use. And you will get an error at startup if you try to load multiple file system modules. Okay, so just like in the sense of orienting ourselves to what's going on here, we've got a file system. We've got like a file system definition. We've got arguments, or I guess configurability. Subscriber exception handler, get event bus and async. Okay, so get event bus and async exception handler is going to return a handler for an event bus subscriber and async thread exceptions. So is this an event bus that Bazel implements, or is this going to use some sort of bus like at the operating system level? I'm not sure. We've got public void Blaze startup. This is called when Bazel starts up after get startup options, global init, and get file system. So we have these three things that are called. We're going to start. We're going to initialize. There's a global entry point that's going to do some initialization. And we need a file system. And then once we have all that stuff, we're going to call Blaze startup. And we have startup options for the server startup. Yeah. So if I remember correctly, what's going to happen? What happens is that Bazel runs as a server, and you can run it locally. In which case, it just starts a server, and then as you're building stuff, I guess it streams it to the local host, the server that's running on localhost. But then you can also run the server remotely, I guess, as a kind of build farm, and both, I guess, use the same underlying code. So Blaze startup is going to take startup options, version info, an instance ID that has a unique name. It's going to take the file system that was somehow found, I suppose, by get file system, and some server directories. So the install directory, I guess, is this where Bazel's going to install stuff, or where Bazel is installed? I'm assuming that if Bazel's running, it knows where it's installed. So this is I suppose, where Bazel is going to install things. And then it's got a clock, and you can inject the clock into the startup function, presumably to make it easier to do testing for crazy clock events, like clocks that go backwards in time, or functions that need to wait. You can pretend to wait by having a clock that advances quickly or whatever. And it throws an abrupt exit exception, which I've never seen before. I'm guessing this might be a Bazel specific thing. Just out of curiosity, let's look for abrupt exit exception. Yeah, yes. Search only for the single search term. Thank you. Okay. Spawn strategy registry. Yeah, this seems to be only for Bazel code. Okay. So this is telling you that something exited and it was more abrupt than expected. Okay. And then server, and it's going to initialize the new server. And modules can override this method, okay, to customize how servers are configured. Sets up so initialize rule classes. It's going to set up the configured rule class provider, which contains built-in rule classes, aspects, configuration fragments, and other things. Called during Blaze startup. After Blaze startup. Then we have workspace init, which is going to, I assume, initialize the workspace file. Or not the workspace file, but the workspace that the file configures. So called when Bazel initializes a new workspace. This is only called after server init. Okay, and then before command is called to notify modules that the given command is about to be executed. This allows capturing the event bus command or option parsing result. Cool. And we've got some notion of output listener. It's going to return additional listeners to the console output stream called at the beginning of each command. So to each command, I guess we're calling before command to let people know that we're about to execute a command. And at the beginning of each command, we're going to call, and after before command, we're going to call get output listener. And that's going to return. So before command, I guess, says, hey, we're about to run a command. And then get output listener is listeners to the console output stream. So this is like subscribers, I guess, but not subscribers to everything that this rule is doing, only subscribers to the console output stream, I suppose. Okay. And then we have an output service. There can only be one output service. It's an error if more than one module returns an output service. Returns extra options this module contributes to a specific command. Okay, so what is this function? Get command options. And then we've got, all right, after analysis, which is called after Bazel analyzes the build's top-level targets. After it analyzes the top-level targets. I'm not positive what top-level means, but I'm guessing this doesn't include things like transitive dependencies. This is called once per build if -- analyze is enabled. Okay. So when we're done with analyzing the top targets, we call after analysis, and then we call after top-level target analysis, which is called after Bazel analyzes a single top-level target. Okay, so this is called per target, I guess. This after top-level target analysis. And then after analysis sounds like it's called after everything at the top level is analyzed. Executor init is going to be called when Bazel initializes the action execution subsystem, which is called once per build if action execution is enabled. Okay. I'm not sure what it means to disable action execution, but maybe we will find out. Maybe. We can register action contexts. We can register spawn strategies. After each command, we call after command. But we also have command complete. But what's the difference? This is called after command. Okay. This method can be used to close and clean up resources specific to the command. Okay. It's not obvious to me, if I were reading this. I mean, you have to read the code comments, but it's not obvious that like command complete should be called after command. But that's the way it is. Blaze shutdown on crash, and posts build metrics event. Returns true if the module will arrange for a build metrics event to be posted after the build completes. The Blaze runtime ensures that it has exactly one module for which this method returns true, substituting its own module if none is supplied explicitly. Okay, so we have something that looks like it collects metrics about the build, and it's called returns true if the module will arrange. Okay, so this is I forgot I'm looking at a module. So these functions are all defined for each module. And if you want your module to collect information about build metrics, you make this function return true. And all right, get query runtime helper function returns a runtime helper factory that will be used by the query, cquery, and aquery commands. Okay. I'm wondering if each module is able to handle. Oh, no. It's not that each module is able to have their own factory. It's that each module can access the helper factory. Okay. That makes more sense. And we've got get package settings, and which is called once during server startup, sometime after server init, sometime. Okay. And we've got, I'm not sure what yes, I think I do know what a package is. I think a package is more or less a thing that has a build file. Let's maybe look that up. Nested hierarchy of packages. Each package is a directory that contains a set of related resource files and one build file. Yeah, okay. So a package is basically stuff that has a build file. So we can validate packages, get package overhead estimator. This, I guess, returns whatever this class is, package overhead estimator, which is used to estimate the cost of loaded packages. And okay, I think I got to go for now. I'll continue this at a future date.